Hello, this is a recording of a short teaching video for the purpose of applying for a mentorship at Udacity. So I decided to give a short demo introductory of how to perform exploratory data analysis, which is a part of a data analyst nano-degree syllabus. So I will explain 5 points. I will go into what exploratory data analysis is and why is it important. Then the tool for utilizing and creating a exploratory data analysis will be R programming language, and we will use RStudio as a development environment to use something called tidyverse to explore or to perform an example of exploratory data analysis on a data set called diamonds. So let me first explain what is exploratory data analysis, or it's commonly abbreviated by EDA. So it is exploratory data analysis refers to the critical process of performing initial investigations of the data so as to discover the patterns within the data and to spot anomalies and to test hypotheses and to check assumptions with the help of summary statistics and graphical representations. So before we even can start, we need to go to our friendly Google and try to install R programming language locally or on our computer. And we can do that by just typing in R-CRAN, and we go to Comprehensive R Archive Network. And depending on which platform do we have, in my case I have Windows, so I will download R from here, the base R. Once you download it, you just install it. And then second step is going back to our Google and then to install the integrated development environment, which is called RStudio. So here we download it. We download the free version, and we again choose whatever platform do we have locally. In my case, it's Windows. So after that has been installed, I will just explain what kind of packages we'll be using to perform exploratory data analysis. So there is something called a tidyverse, which is an opinionated collection of our packages. So it is a collection of our packages designed for data science, and all packages that are a part of tidyverse, they share an underlying design philosophy, grammar, and data structure. So this package, once we go to RStudio and install it and load it, will also contain all necessary libraries, and there is a really good set of resources in an online free book called R for Data Science. So you can just open it by clicking this particular link. It is an amazing book, but just to give you a brief overview, so we'll be using, so this is the whole workflow that this library or a set of libraries covered in tidyverse is actually encompassing everything from importing the data, cleaning the data, transforming, visualizing, modeling, and also creating various communication packages or environments. So we'll be just using examples from tidyverse, and let's do an example. So after installation of RStudio, we just open it. We create a new project. In whatever directory you prefer. I will name it Udacity Mentoring. Okay, so now we created a new project, and this is the RStudio environment here. So we'll create a new script and initially save it so we can run scripts. Okay, once we saved it, now we can do all sorts of things within the studio. So we have four. So the entire RStudio is divided in 4 panes. You have in this here, you have a script, then you have in the lower left corner console, and here you have various environmental overviews and viewer here. So once you create certain plots, it will pop up here in the lower right corner. So first we install tidyverse, and we install it by either running it here or in console, since usually when you install your packages for the first time, you do it only once. After you install your package locally on the machine, then every time you go into your session, you just need to load a library, or in this case, a package of libraries. So we will install tidyverse, but before that, we can just check if we have it. Maybe we have it. So we load the library or the tidyverse in this case by just writing library, and in the brackets we type in the name of the package, and then we just run it by either clicking run here, or we can use the shortcut of the keyboard Control Enter. It seems that I already have it installed, so it loaded it. But in case you haven't had it, then you just use this command, install packages, and in the quotation marks you put the name of the package. So let's try to do that. Here it just asks you that he would like to reset the state and R prior to the installation. We just click yes. And now it's installing the packages in our local C location. And it says it has been successfully unpacked. So now we can just load the library one more time to make sure. Okay, so as I said, it says now here that everything has been loaded. There are some conflicts for the functions, but that's not something that we need to worry about in this case. So we will load, there are a few data packages as a part of this library that are used for educational and demonstration purposes. One of them is called diamonds. So if we just type in diamonds, it says here a dataset containing the prices and other attributes to almost 54,000 diamonds. So we just Control Enter, and in the console we see a table containing 53,940 rows and 10 columns associated with the diamonds table. We have the names of the variables or of the columns here, and below each variable you have a data type. So you can immediately get an overview of what kind of data types are defined per column. Okay, so let's do a demonstration. So what I will do now, I will try to filter the dataset by, let's say, cut, which is equal to premium, and then I will do a summary statistics. I want to know what is my mean value. So let's do this. So we put the data on our first position, and then we use something called a pipe operator, which will just put the data in the first argument of the second function. So we use the function called filter, and then we can filter the column cut equals premium. And then we just run the entire the entire, I misspelled it here. So we'll get a subset of data, 13,791 rows that contain only premium cuts of diamonds. And then I would like to use this subset of data and apply another function on it. So I would like to calculate the column called volume that is based on multiplication of X, Y, and Z columns. And we can do that by using a mutate function. And then we create a name of the new column. And this is going to be volume, and it will be a multiplication of X column, Y column, and Z column. And now we run it and we see that this is our new column, and it is a multiplication of the X, Y, and Z dimension. And the third part, I wanted to get a mean of these volumes. And we can do that by using the summarize function. And we just create what is the name of the new variable that will be calculated, and we can call it average volume equals mean is a function, and we want mean of volume. So we get it's 145 is the mean of the volume. But now I would like to actually plot it. I'm curious about what is the distribution of these diamonds that are premium cut, and what is distribution of their volume. So now I just copy and paste the chunk up until I created this volume column, and then I use a ggplot library and a function in this case to see the distribution of the volume. And then we use a geom histogram in order to calculate and plot the distribution of the volume. So let's see. So you can see that in this pane we can see what is the distribution of premium cuts of the volumes. And then if you want to plot the mean, we can do that by using geom vertical line, and in the x-intercept we can just plot our value which was 145, and let's color it by red. And now we see where is our mean value with respect to our distribution. So this was a short example of exploratory data analysis using R Studio, Tidyverse, and Diamonds package. Thank you very much.